there's additional information that I just want to inform, is that when you plot, if you still remember, this one is your z plot. Alright, when you plot in terms of tests, when they ask you to plot, maybe they call you to plot this point. Alright, sorry, be very careful that when you plot, you're going to plot in terms of some dots. Alright, and then you link them up like this. Alright, although I don't know whether you can straight away draw this or not, but you please remember that if you were to draw this straight line, alright, please also includes the point. Alright, these little points over here. If not, you're gonna tell the marker stating that it's a continuous system. Alright, these are all continuous system. Or however, if you put in the dots, you're just informing people, telling that this is a digital system. Alright, this is the very important concept that I just want to convey, in case that soon careless mistake may occur. I don't know. Anyway, the next thing I just want to convey is, how do you use this chart? At what occasion will you use this chart? Alright, this is still regarding your particular that circle over here, but because it's a damping factor, there may be something like this and like this, things like that. Alright, but I just want to convey when do you use this thing. Normally when you're given a certain transfer function, maybe this is like 2s squared plus 5s plus 6. Alright, you still remember this is a general equation for the second order system, correct? And therefore you can find your natural frequency. So you know that your natural frequency square equals to 2. So therefore the natural frequency is equals to square root 2. And from here, then you can simply take a look. This is your natural frequency. Is equals to pi over 2t. So this all of these things over here are your natural frequencies. Alright, if didn't actually explicitly define, hopefully I do now. Alright, so this red, maybe I should use a different color. This thing over here, all these lines, alright, that comes out from all this here. Alright, all of this are your natural frequency. Alright, these are all your natural frequency. So how the frequency intersects, I will tell you whether where are you at, are you safe or not, and things like that. Alright, and the other way to look at things is, if you were to find your frequency already, you can find your damping factor. Alright, and in the cross section of it will tells you which point are you at and whether are you safe or not. Alright, so the next step you're going to do is to find the damping factor. So the damping factor is this line over here. Alright, it's all this thing. It's all this line, I think you get what I mean already. It's all this thing. So when it intersects at this point, this tells you that, so when your damping factor and your natural frequency intersects, this means that this is the point on your z domain, or your circle over here. This is the point. Alright, and this is your pole. And this is the one method of solving your stuff if you have certain function over here. Alright, so when you are given this thing and they ask you to plot inside this thing, don't be scared. Alright, it's just this method of doing. Otherwise, you can somewhat solve for this thing and transform them into the z domain, and then simply plot it inside your stuff over here. Alright, and as simply as it may sound, you need to rearrange this stuff, because it's not that simple at all. You're going to rearrange in terms of some maybe 1 over s plus 2, and then plus 3 over s, and then you transform back to the time domain, and then from there, or from here you can use the table. Alright, I'll highly suggest you click this. I don't know where's my link now, never mind. Go to your where is it? It's a week 5. Alright, you just click this link, and eventually it will bring you to the table, alright, of your z transform. Okay, so for example, like 1 over s squared, you can z transform into this one. Alright, and then you just do things with it. I also don't know what the hell is going on. But once you get this already, I think you may need to calculate something in order for you to get the plots of the poles and things like that. I don't know, I'll leave you to think about it really. So this is something that upon this time I know something about this. Alright, so I'll update you with other stuff if if I know anything more. Alright, so I'll just keep this in mind, and yeah.